Welcome back to Techiexpert. I'm Alicia. Google AI recently introduced their reinforcement learning world model to encapsulate rich and meaningful information about surroundings, which enables a learning agent to make its specific predictions about actionable outcomes within the environment. The world model, known as Pathdreamer, is an indoor navigation world model that generates high-resolution 360-degree visual observation of areas of a building unseen by an agent using only limited seed observation and proposed navigation trajectory. The model can be synthesized an immersive scene from a single viewpoint, predicting what an agent might see if it moved to a new viewpoint or even a completely unseen area, such as around a corner, beyond potential application in video, editing, and bringing photos to life. Solving this task promised to codify knowledge about human environment to benefit robotic agents navigating in the real world. When a person navigates around an unfamiliar building, they take advantage of many visual, spatial, and semantic cues to help them efficiently reach their goal. For example, even in an unfamiliar house, if they see a dining area, they can make intelligent prediction about the likely location of the kitchen and lounge areas and therefore expected location of a common household object. For robotic agents, taking advantage of semantic cues and statistical resolution in novel buildings is challenging. A typical approach is implicitly learning what these cues are and how to use them for navigation tasks in an end-to-end manner via model field reinforcement learning. However, navigation cues learned in this way are expensive to learn, hard to inspect, and difficult to reuse in another agent without learning again from scratch. An appealing alternative for robotic navigation and planning agent is to use a world model to encapsulate rich and meaningful information about their surrounding, which enables an agent to make specific prediction about actionable outcomes within their environment. Such models have seen widespread interest in robotic simulation and reinforcement learning, with the impressive results including finding the first known solution for a simulated 2D car racing task and achieving human-level performance in Atari games. However, game environments are still relatively simple compared to complexity and diversity of real-world environments. In Pathdreamer, a world model for indoor navigation published at ICCV 2021, they present a world model that generates high-resolution 360 visual observation of areas of building unseen by an agent using only limited seed observation and proposed navigation. Let's see, for example, a robot tasked with finding a particular room or object in an unfamiliar building could perform simulation using the world model to identify likely location before physically searching anywhere. World models such as Pathdreamer can also be used to increase the amount of training data for agents by training agents in the model. So how does this Pathdreamer all-rounder work? So Pathdreamer takes an input sequence of one or more previous observations and generates prediction for trajectory of future location, which may be provided up from irrelatively by the agent interfacing with the returned observation. Both inputs and prediction consist of RGB, semantic, segmentation, and depth images. Internally, Pathdreamer uses a 3D point cloud to represent surface in the environment. Points in the cloud are labeled with both their RGB color value and semantic segmentation class, such as wall, chair, or table. To predict visual observation in new location, to the point cloud is first reprojected into 2D at new location to provide the guidance image from which Pathdreamer generates realistic high-resolution RGB, semantic segmentation, and depth. As the model moves, new observations, either real or predicted, are accumulated in the point cloud. One advantage of using a point cloud for memory is temporal consistency. Revisited regions are rendered in a consistent manner to previous observation. Finally, the Google AI team tested if Pathdreamer prediction could help with a downstream visual navigation task. Using the R2R dataset, they focused on video and end language navigation (VLN) because achieving the navigation goal necessitates properly anchoring natural language commands to visual data, masking task-based prediction quality. Assessment tricky. The main characteristic of R2R, that is room-to-room dataset, is that here the agent prepares ahead by simulating various alternative possible paths to a given environment and ranks each against the navigation instruction provided to find the optimal path. The researchers examined the following 3 situations as a part of the experiment. Then, the ground truth setting in which the agent plans by the interaction with the real world, that is through moving, the baseline setting where the agent processes forward but does not move. Instead, it interacts with the navigation graph which records the building's accessible path but provides no visual observation. Pathdreamer setting in which the agent interaction with the navigation graph and receives suitable visual observation produced by Pathdreamer to plan ahead without moving. According to Google AI researchers, when the agent prepares ahead for the steps in the Pathdreamer mode, it has 50.4% navigation success rate. This result is much higher than the baseline setting, that is 40.6% rate, including Pathdreamer. This indicates that the Pathdreamer stores visual, spatial, and semantic information about the real-world interior locations in a meaningful and accessible manner. In the ground truth setting, the agent has a 59% success rate. This result showcases the promise of using world models such as Pathdreamer for complicated embedded navigation tasks. We hope that Pathdreamer will help unlock model-based approaches to challenging embedded navigation tasks such as navigating the specified objects and wheel and applying and etc. Pathdreamer to other embodied navigation tasks such as object, new continuous wheel and street level navigation and natural direction for future work. We also envision further research or improved architecture and modeling direction for the Pathdreamer model, as well as testing it on more diverse datasets, including but not limited to outdoor environments. So that's it for today. I hope you enjoyed this video. Don't forget to like, share and subscribe to Techiexpert. I am Alicia and thank you for watching.